This is example problem number 3 for lab number 1. And it's actually much simpler than the first couple examples. Let's take a look at it. So a tabular ore body strikes 293 degrees. 293, if this is north and that's west, 270, 293 is about like that. Okay? It's going to dip to the southwest towards me. All right? And it dips 28 degrees towards me to the southwest. And here's the various other ways that could be expressed. Okay. And by the right arm rule, that would be expressed 113.28, because if you take the the direction of my pencil to have meaning, right? That's in 113 now, an azimuth of 113, and if you face in the direction of 113, your right arm would dip toward the southwest. So that's fine. Makes sense. The ore body has an outcrop width of 22 meters. So it's going to have a width here, 22 meters. Assume that the surface is horizontal and featureless. And actually, we've made that assumption in all of the examples so far. In what depth interval would you expect to find the ore in a vertical hole drilled at point A, just some point, that is 53 meters, so it's out here, 53 meters southwest of the ore's upper contact, in the direction of its dip. So that does imply that it's out here. Of course, 53 meters in the other direction, you'd never hit it because it's above the surface over there. So it's got to be over here. Here's what makes this problem a little different. We're given dimensions, and we're expected to get dimensions out of the drawing. Therefore, this construction needs to be a scale drawing. We have to preserve dimensions in this one. So I'm anticipating, again, this ore body right in here. Other fold line this way and so forth. Point of origin somewhere in here. Let's install a north arrow somewhere right in here for reference. And, I don't know. I'll just use this 8 centimeter distance to make this nice and parallel. That's 8 centimeters. Draw that. And I'll just draw right through that wording. So that is north. Okay. Let's arbitrarily pick a point of origin. It'll be right there. Let's put our strike in, 293. 293 will be what? 23 degrees above due west, right? 270 plus 23 would be 293. So I think that's the way I'll do this. I could do it differently. I could, for instance, that's also what? North 67 west. Okay, let's do it that way. North 67 west. 60, 65, although it's kind of hard to see. I'll tell you what I'll do. Just for the sake of drawing this, let's just do this. North 67 west. Will be 65, 6, 7 will be right there. All right, so that's North 67 west. And that, of course, I'm going to lift that tab in a second. That is that line right there. North 67 west. Okay? Okay. And I'll tell you what, I may install a little strike and dip symbol to suggest that that dips this way. And what was my dip? 28 degrees. So that dips 28 toward the southwest. I need to design a scale that I think will work here. And this may be cutting it kind of close, but I am going to pick 2 centimeters is 10 meters. That means 2 millimeters are equal to 1 meter. So 2 centimeters is 10. Let's see. So that's 10, 20, 24. That should be 22 millimeters at that scale. So basically what we're saying, we've now got a scale established, and I hope it works. You've got a scale established where 1 centimeter equals 5 meters. 2 centimeters equals 10 meters. All right. Okay, so we did that at 4.4. If I just draw a line parallel here, 4.4, that line will also be, oh, it doesn't look right, does it? Let's do that again. 4.4. And, well, that should be right. 4.4. Well, I guess so. It just doesn't look right. I guess it's an optical illusion. This is then the upper contact right here. Also dips over in this direction 28 degrees. This is upper. I'll say UC, upper contact, LC, lower contact. Now we need a fold line. And the fold line, it needs to contain the value of dip correctly. So the fold line needs to be in the dip direction. And let's just put that in here. I can just do it this way. That fold line is going to be and I might have to make it longer. The fold line's going to be right there. Okay. Very good. Let's put the dip in here. The dip is 28 degrees to the southwest. So that 28 degree angle is shown right here. And the the lower contact, where I am right now, 10, 25, 6, 7, 8, it's right there. That's going to be the lower contact. Right there. And I could do the same thing here, but I might double check and make sure the 2 contacts are parallel to be. 28, 25, 6, 7, 8, right there. And that should be the upper contact. And again, I'm going to draw that in light to begin with, and just make very sure that those 2 contacts are parallel. If they are, I will commit to it. Oh, you see that? I'm going to make that. Come up just a little bit. All right, there you have it. So the way this drawing is now, again, this is the surface. Yellow. Let's say this is gold ore. So I hope this doesn't mess me up. That I just highlighted the gold ore side of is the upper contact, and this then is the upper contact. Right there. This, of course, then is the lower contact. And this, correspondingly, the lower contact. This is all ore in here, and this is the outcrop pattern of the ore. So this is 22 meters wide. That is actual width. Right, 22 meters wide. Very good. And this then, I can already, I mean, if I were interested in the thickness, it would be this dimension right here. And that thickness is 10.5 meters. So that is 10.5 meters. I'll say T equals 10.5 meters. I'm not even asked that in this question, but that's true. The thickness of the ore measured perpendicular to its upper and lower contacts is 10.5 meters as per this scale drawing. The question that we're really asked about is at what depth interval, right? In what depth interval would you expect to find the ore in a vertical hole drilled at point A, 53 meters, southwest of the ore's upper contact, which is this one. And so let's establish where that is. 53 meters. So, tell you what, just for the sake of measurement, I think I'll start with 0 over here. And for whatever reason, 10, 20, 30, 40, 50, 51, 52, 53. That is right there. So this is a point by my scale drawing that is 53 meters in the direction that was specified. So that is 53 meters from the upper contact. And there, oops, there. So there, 53 meters. So that is this point A. That's where we're going to drill a hole. And we're going to drill the hole vertically. It says a vertical hole drilled at that point. Well, if that's the horizontal surface of the Earth, then a vertical hole, and I'm in the habit of doing this, for a problem like this, what I'll tend to do is draw what has a technical meaning of a center line. That's the center line of the drill hole. And I will have to extend it in that direction to penetrate the ore. And if I even wanted to put, at least in a schematic way, of course the hole is probably infinitesimally small at this scale, but I tend to do this kind of thing for this kind of problem. So there's my drill hole. Okay? Now, to address the actual question, all I have to do is measure. So in this hole, we will penetrate the top of the ore at a depth of 10, 20, 25, 26, 27, 28, about 28 meters. A little more, 28.5 meters. Is that about what that is to the center line? All right, 28.5 meters. That's to the top. And the bottom, I will penetrate at 20, 30, at 40, about 40 and a half meters. So there you have it. In what depth interval? In what depth interval would you expect to find the ore in a vertical hole drilled at point A? That's that point right there. 53 meters this way. We got that. Southwest of the ore's upper contact in the direction of its dip. Well, that would be, that interval would be 28.5 meters to 40.5 meters, as per this scale drawing. So the only other thing I wanted to show you is the use of this as a fold line. So you recognize this as basically the same construction we just did. As it turns out, when I did this before, rather than 28.5 meters, I found 29 meters. And rather than 40.5 meters, I had 40 meters. So again, I wanted to show you the use of this as a fold line. So all I'm going to do is fold this along that line, place it on the edge of the desk, and then I'll show you the other perspectives. So there's the top view, map view, right? That's the surface of the Earth. It shows the tabular ore body, upper and lower contact. You'll recognize that as, you know, basically the construction we just made. But what I want to show you is what the cross-section looks like. This then is the other projection that we had in our